Okay folks, so in this particular video I will show you how to do ratio problems where you're given a certain information and you're expected to kind of know the outcome and make a comparison. Alright, so if you want, pause, read, and then look at all the different parts there. Okay. So here we have a car that's accelerating to the right with some constant acceleration a, and the value of a is not given to us, it's just vague, it's just a. And it says if the car covers a distance of 2.5 blocks, okay, so in this case it's just some unit of blocks in a time of 6 seconds, and it says determine the following. So the scenario is that you start at 0, your initial velocity is also 0, and you essentially hit the gas pedal, and in a time of 6 seconds the car has accelerated a distance of 2.5 blocks, and it wants us to find all these different ratios, okay, or values. Alright, so let's go ahead and do it. So I'll do A and B on this one. Alright, so to find the distance, aka in units of blocks, that's covered in 3 seconds, we can just set up a before and after ratio. So you notice here in the diagram, it's from 0 to 6 seconds, it covers 2.5 blocks, but part A asks us the distance covered in 3 seconds, which is half the time. So I'm expecting an answer less than 2.5 blocks, so let's go ahead and do it, okay? So here I have set up a before and after. My before, aka my baseline, is something I reference in class. Find a starting value to start with, and then you can reference everything based on that starting value. Alright, so here's your displacement function, VIT plus 1/2 AT squared. In this particular diagram and the wording, it says that it starts from rest, so we can cross out that VIT term, which leaves us with just delta x, aka your displacement, is equal to 1/2 AT squared. I went ahead and substitute delta x here because the diagram gives us a reference point. At 6 seconds, the car has accelerated a total distance of 2.5 blocks, which in this case is the same as your displacement because the car, again, is just accelerating to the right of the screen. Okay, so here's the statement. I don't know what A is, so I really don't know. I mean, you could find it in terms of blocks over seconds, but that's not the point. The point is for you to just find these values without cranking out calculator work. Okay. All right. So here in the after, aka my new scenario, so part A asks us to find the number of blocks covered in 3 seconds. Here I set up the whole displacement function all over again, except here I've used subscripts, aka the new, because there's a new scenario. Okay. I went ahead and crossed out VIT because VI starts at 0, and here I simply substituted T new. Well, this is the struggle that students often have. How do you write the new time in terms of your given value, your reference point? Well, part A says 3 seconds, but the diagram gave you a reference point of 6 seconds. So to me, 3 seconds is half of 6, hence T over 2. Again, taking the time that was given, which is 6, and I want to just chop that in half. Okay. So that's important. So if you don't know how to do this skill, pause the video and really think about how I arrive at T over 2. Okay, so 3 seconds is half of 6. 6 being T because that's what T is in this diagram. Alright, here with just basic distribution property, I'm going to distribute the square to the T. I'm also going to distribute the square to the 2 in the denominator. You have to distribute the square to both the terms here because you're dividing in the parentheses. So here I have t squared, and then 2 squared is simply 4. And what I can do is this trick that hopefully you'll pick up after watching this video, is you can just extract coefficients. Okay, so t squared divided by 4, I can pull out a factor of 1 over 4. And then the 1/2 is right here where my cursor is going back and forth. The a remains the same. And then t is in the numerator, so I can just rewrite it as that. And then you just have to start recognizing what is the same as your baseline. Well, 1/2 AT squared is the same as the left side of the chart, okay, aka your starting point. 1/2 AT squared, that's your reference point. But 1/2 AT squared is equal to 2.5 blocks. So what I have highlighted in blue here, 1/2 AT squared, represents 2.5 blocks because of the statement on the left. It says 2.5 blocks equals 1/2 AT squared. So the opposite statement is true. 1/2 AT squared equals 2.5 blocks. So it doesn't matter how you say this equal sign. Okay. All right. So what I can do is substitute the blue box here, the whole quantity, 1/2 AT squared, for 2.5 blocks, because that's a true statement. So the coefficient 1/4 in the front, again, just comes from my previous distribution. The 4 in the denominator, that's the same as 1/4. And then here I have 1/4 times 2.5 blocks. And if you crank that on the calculator work, you should get a value of 0.625 blocks, which makes sense. Earlier, I did say that I'm expecting a value less than 2.5 blocks, okay, because the time is only half. I also want to point out a misconception that kids may have. Well, if it asks for 3 seconds, the big misconception is that kids might take 2.5 blocks and divide it by 2. That's a big no-no. A car's accelerating, so therefore your velocity is not increasing at a constant rate. So therefore it covers different distance, in the same amount of time. From 0 to 3 and from 3 to 6, it's the same window of time, except from 0 to 3, the car is barely picking up speed. So it's going to cover less distance because it's barely getting going. However, from 3 to 6 seconds, it's now moving faster and faster and faster. So therefore, it's going to cover more distance in the same time interval. Okay, so from 0 to 3, it covers a little less, and then from 3 to 6, it covers more. So the big no-no is don't just take 2.5 blocks and simply divide it by 2. So listen to that again if you need to. Alright, so that's part A. Part B, again, we're going to use the same procedure here. Let's set up our baseline. Displacement is going to be VIT plus 1/2 AT squared. Let's cancel VIT out because VI starts at 0. And then delta X here, my reference point is 2.5 blocks as given. And then the right side reduces down to 1/2 AT squared. And I want to stop there. That's my reference point. Everything I'm doing references the statement. Okay. On the right side, well, we have X new. Part B asks us the amount of blocks cover after 12 seconds. That's okay. So we're going to cross VIT out as well. But you notice again, the only variable that I'm really changing is the variable t, because this is the only thing that's different. I kept the 1/2 the same because that's part of the function. I kept a the same. Why? Because I don't know what a is. Again, you can technically find it, but the point of this video is to show you how to find these values without doing a lot of calculator work. T new squared. But the t new is now 12 seconds. Okay, so part B, time is 12 seconds. But without thinking too hard and overcomplicating it, well, 12 seconds is just 2 times 6. So it's just twice the amount of time. So in mathematics, how do you express twice of something? Well, you literally just multiply by 2. So I carry X new down here. I carry the 1/2. I carry A down. And you notice here in the parentheses, instead of writing T, well, I substituted T new for 2t, because 2 times 6 is 12, which is a true statement. Okay, so here, once you find out that true statement, everything else just comes, well, it just becomes algebra really. So here we have to distribute the square term, the exponent to both the 2 and the t. So 2 squared is going to give you 4, and then t squared is just t, which I've rewritten there. But you notice here, a lot of stuff, 1/2 is the same, a is the same, t squared is the same, but now you got this coefficient of 4. So you just have to learn to pull out this coefficient to look like this. Put it in front of the statement, and then rewrite everything else, which is going to be your baseline. 1/2 AT squared is your baseline, aka your reference point, which is on the left side of this table again. But 1/2 AT squared is simply 2.5 blocks. So you're just gonna do an easy substitution. Carry the 4 down. Wherever the 1/2 AT squared is, you're going to replace it with the true statement, which is 2.5 blocks. So here, X new is equal to 10 blocks. Okay, so because the displacement function is a quadratic formula, doubling the time is actually going to quadruple the number of distance covered. Okay, in this case, if the unit is blocks, if it starts off at 2.5 blocks, doubling the time is going to quadruple it, so it would be 2.5 times 4, which is going to equal to 10 blocks. Okay, all right, let's do C. C here asks again, how many blocks are you going to cover in 18 seconds? So set up the same procedure. Start with the reference point, aka the before. Cross VIT out, 1/2 AT squared, which is in this case is 6 seconds, but I don't really care for substituting in the t. That's my t. I'm just going to call it t. A, I don't care. I'm just going to call it A. Okay, so now you're just going to set up the right side of the table, aka X new. But keep in mind, part C is 18 seconds. Well, we're still starting back at 0 seconds, so VI is gonna disappear. It's just 0, so 0 times T is 0. 1/2, it stays the same. A stays the same, but here's T new. Well, 18 seconds, that's just 3 times 6. So I can replace T new with the statement. Well, 3 times the original time, and the original time here being 6 seconds. Okay, so it can be any value you want. It doesn't have to be 6 seconds in this diagram. I've just chosen it as 6 seconds, but it doesn't really matter what the diagram makes T to be. So we're going to distribute the square to the 3. We're going to distribute the square to the T. 3 squared is 9. That's where the coefficient 9 comes from. And then T squared, I carry down here. Again, you notice here the only thing difference is the 9 inside the statement. The 1/2, the A, the T squared stays the same, and there's the 9. So rewrite it in front of the 1/2 AT squared. Now, this is useful again because hopefully by now you recognize this procedure allows you to rewrite stuff in terms of your baseline. Okay, so 1/2 AT squared is just simply 2.5 blocks. Well, in that case, let's go ahead and replace that blue box with a true statement, 2.5 blocks. So in my work, I have X new here, which is equal to 9 times 2.5, and calculator work is going to give us a value of 22.5 blocks without having to punch in A, without really having to punch in T. Okay, all right, so that's the answer for part C. Part D asks us, well, what is it in 27 seconds? Well, how do you know what that coefficient is? Well, your reference point is 6 seconds. The time given here is 27 seconds. So really, all you have to do is take 27 divided by 6 to find the multiplier. Okay, so same procedure as we've done before, except this time it's 27, so it's not going to give us like a nice whole number, but it's okay. Set up your before and after. Okay, so I'm going to skip the left side here because I've done it a few times already. On the right side now, VI is going to cancel out. T new here, this is where the hard part is. Well, how do you know what T new is? Well, 27 seconds, your reference point is 6, so take 27 divided by 6, and that's your multiplier. So therefore, I've done it for you. If you punch in 27 divided by 6 seconds, you'll get 4.5. 4.5 what? 4.5 T, aka your reference point, your original given value. Okay, and then I'm going to square 4.5 because again, there's a power of 2 on the outside of the parentheses, so make sure you distribute that. So 4.5 squared is going to give you 20.25, and then T squared is going to give you T squared. The only thing different that I've seen in the last few processes, this coefficient of 20.25. Well, let's pull it out the front. So 20.25 times 1/2 AT squared. The 1/2 AT squared again represents your reference point, your baseline, which in this case is 2.5 blocks. Okay, and then from here we can just replace the 1/2 AT squared with 2.5 blocks. Therefore, 20.25 times 2.5 blocks is going to give us 50.625 blocks. So that's the answer to D. So as you can see, hopefully you kind of understand how to set up a before and after statement. Only change what it wants you to change. In this case, A, B, C, D have only changed time. It hasn't done anything else except for making it some multiplier of the original given value, which is 6 seconds. All right, let's do part E. Okay, so part E here asks us to find the distance ratio between the first 6 seconds and then the second half of this, an additional 6 seconds, from 6 to 12 seconds. Okay, so here from 0 to 6 seconds, and then here from 6 to 12 seconds. That's okay, easy work. Okay, so here in my chart I have from 0 to 6, and then I have from 0 to 12. Well, 0 to 6 we already know, right? The problem starts at 0 second. The time here in the diagram is 6. So therefore, we already know the distance is 2.5 blocks. Okay, but I went ahead and set up for you just in case you need it. Delta x equals VIT plus 1/2 AT squared. VI cancels out because it's 0. Therefore, 1/2 AT squared is simply going to equal to 2.5 blocks. Well, let's set up the right side. Okay, the right side, I'm going to go from 0 to 12. And there's a reason why I'm going from 0 to 12. If I can go from 0 to 12, and if I know the distance from 0 to 6, which is given, then I can just do a simple subtraction. So keep up with this process. Here, if I start at 0 second, my VI is 0. And then T new is going to be 2T. Again, T new here being 12 seconds. I want to go all the way from 0 to 12. Well, 12 divided by 6 is 2. Therefore, that's where that 2 comes from. distribute the power again. So you're going to get, 1/2 a 4t squared. Pull the 4 out in front of it so it's just nice and easy to look at. Recognize that the 1/2 at squared is your baseline, which is 2.5 blocks. So here we have again 10 blocks. I've done this process for you already. But this part's a little different. You're not done here. You have to do a little extra thinking. The red arrow that just came up on the screen, well, that's from 0, to 12. Well, hypothetically speaking, if from 0 to 12 is 10 blocks, okay, then I know that I need to find this distance, okay. Well, how do I find this distance here? This is from 6 to 12 seconds because that's what the statement is saying. The second statement on the right side says from 6 to 12. Well, I just found the distance from 0 to 12 seconds, which is 10 blocks. I need to find this distance. Well, how do I find that? That's easy work. Well, the gap here, watch my cursor. From 0 to 6 seconds, it's given as 2.5. So what number do you have to add up to give you 10? Well, this black line must be and has to be 7.5. Therefore, it makes sense. So from 0 to 6 seconds, you've covered a distance of 2.5 blocks. And then from 6 to 12 seconds, you're going to be accelerating faster and faster. So you're going to cover more blocks as time goes by because you're gaining speed. So therefore, from 6 to 12, you've covered 7.5 blocks. Well, in that case, let's just do the statement. The left side of the function says 0 to 6 seconds, which is the distance equal question mark. Well, 0 to 6, 2.5 blocks, which is given. And then from 6 to 12 seconds is 7.5 blocks. So if I just lost you, you want to go back and listen to how I arrive at 7.5. Here's my heart. To find heart, divide both sides by 7.5. Therefore, heart is going to equal to 1/3 or 0.3333, however you want to express your answer. So that's the answer. Let's do part F, okay? Part F here asks us to find the ratio between the average speed from 0 to 2 seconds and the average speed from 2 to 4 seconds. Well, you notice here the time of window is less than 6, which means my work is going to be in this region between 0 to 6. Okay, so my distance cannot be bigger than 2.5 blocks, so we'll see. To find average speed though, you need 2 quantities. You need distance and time. Well, the time interval for the left side of the statement is 2. The time interval for the right side statement is also 2 because from 2 to 4 is 2 seconds. So really all we have to do is find time, right? In these type of statements, the time interval is given to you. Alright, so let's do it. I'm going to go from 0 to 6 again because that is my baseline. So from 0 to 6, I know the distance is 6 blocks. However, I'm going to go from 0 to 2. Why am I going from 0 to 2 seconds? Well, I need the distance from 0 to 2. So in order to find average speed from 0 to 2, I need distance and time. I know the time. Time's already 2 seconds. So I need to find the distance. So I'm going to set up my displacement function. Because I start at 0, my VI is going to be 0, so I'm going to cancel that out. And I'm going to plug in t over 3. Now, this is where if I've lost you, you want to listen carefully. Well, I went from 0 to 2 seconds. Well, 2 seconds is 1/3 of 6. Okay? Or you can simply say 2 divided by 6, which reduces down to 1/3, which is just t over 3. Well, this sits in the parentheses, so I'm going to distribute the power, so it'll be t squared over 9. Don't forget to distribute the square to the denominator as well. So it's going to look like this, t squared over 9. So you notice here again, 1/2 a stays the same. I have a t squared in the numerator. The only thing different here is this 9 in the denominator. Well, dividing by 9 is the same thing as multiplying by 1/9. So I just rewrite that out front as 1 over 9. The 9 still stays in the denominator. The 1/2 at squared stays the same. 1/2 at squared. 1/2 at squared is my baseline. Therefore, I can find my x at 2 seconds. Okay, which is 1/9 times 2.5. So how far has the car traveled in the first 2 seconds? It's only traveled 0.278 blocks. Okay. Now that's useful because again, you need to find the distance in order to find average speed. We can use the same process here in the third column. But I do want to point out here, I'm going to go from 0 to 4. Okay, from 0 to 4 is super easy to do. Okay, I know the statement on the right side says from 2 to 4, but to find the distance between 2 to 4, I'm just going to find the distance from 0 to 4 and then subtract it from 0 to 2. So if I want to start my distance from 0 seconds, my VI 0, and I want to plug in 2/3. Okay. Now, why 2/3? Because I'm going to go from 0 to 4. 4 seconds compared to 6 seconds, it's 2/3. 4 divided by 6 reduces down to 2/3. 2/3 of what? 2/3 of the original time. Which makes sense. If you think about it, what's 2 times 6? Well, 12. 12 divided by 3, which is 4, which makes sense. But here, I'm going to distribute. 2 square is 4. 3 square is 9. T square is just T square. So here I notice what's different is this coefficient of 4/9. Okay, so I'm going to pull the 4/9 down the front. I'm going to keep the 1/2 AT square the way it is. The 1/2 AT square. Hopefully by now we've done enough of this that you recognize that 1/2 AT square can be substituted for 2.5 blocks. So 4/9 times 2.5 is going to give us a distance of 1.11 blocks. Now, but you can't use this answer though. You can't use 1.1 blocks because the 1.11 represents the total distance from 0 to 2. But the statement says from 2 to 4, so you need to know the distance from 2 to 4. So watch what I'm about to do. So to find the average speed for the first segment from 0 to 2, which is super easy, we found the distance in my work here in the middle column. During the first 2 seconds, the car has traveled a distance of 0.27 blocks. Well, the time interval is 2 because from 0 seconds to 2 is an interval of 2 seconds. And if you reduce that down, it becomes 0.139. I left the units out here because the units will eventually cancel out. But you can, if you want, put blocks per second. And then we need to find the average speed from 2 to 4. Now, average speed is distance over time. But you notice here, I kind of color coded differently here. The distance is actually only 0.833 blocks. Why? Because, well, watch this cursor. I just found the distance from 0 to 2 seconds, which represents 0.278. What we know, okay, from 0 to 4 seconds is 1.1, which I calculated on the right side of the column here. But I don't need from 0 to 4, I need from 2 to 4. So therefore, how do you find what this missing arrow is? Well, this arrow is simply the difference between 1.11 minus 0.278. So that's where this 0.833 comes from. So I'm going to say one more time. From 0 to 2 seconds, the car has only covered 0.278. From 0 to 4 seconds, it has covered 1.11 blocks. But I need the blocks from 2 to 4 seconds, so I would just take the difference. Hence, the distance in the numerator here is 0.833 blocks. The time interval for this particular scenario happens to be 2 because it's from 2 to 4 seconds. So it's important that you understand where to start a problem rather than just finding values and not knowing how to interpret these values, okay? All right, so here we have our values. We have two answers, 0.139, we have 0.417. Set that statement up, and then here's my heart, and to find heart, I will simply divide both sides by 0.417. And if you do that and you simplify it, it comes to about 1/3 or 0.33333 if you wanted to do decimal. Okay, let's do G. All right, here we go. Determine the ratio S average from 0 to 6 and then from 5 to 6. Well, this one is light work. All right, we already know information on the left side. The problem gives us the distance from 0 to 6 seconds, which is 2.5 blocks. So you notice here I made this statement. I already know the distance. So if you're looking at the diagram carefully, well, from 0 to 6 seconds, you cover a distance of 2.5 blocks. Well, I don't have to do much work on the left side. I know the distance. I know the time interval from 0 to 6 is just 6. So we'll knock that out in just a second. However, I don't know from 5 to 6 though. But what I can do is do this. I can find the distance from 0 to 5 seconds, okay? Because I can just take the difference later. If I start from 0 to 5 seconds, at 0 second, my VI is 0, and then I'm going to substitute in for T again. T new here is just 5 over 6. Well, why 5 over 6? Okay, so if you're still struggling with this coefficient and understanding where it comes from, you take whatever time is given to you and you just divide it by 6. In this case, it's 5 seconds. Well, 5 seconds is less than 6 seconds. So I expect a decimal. So therefore it's just 5 over 6, aka my reference point. And then there's that t. If you distribute properly, you should get 25 over 36 and then t squared. So 25 over 36 is my quote-unquote coefficient that I've just found. I'm going to pull that out in the front, replace 1/2 at squared with 2.5 blocks. If you do this on your calculator, you should get the new distance of 1.74 blocks. But keep in mind, this is the amount of blocks from 0 to 5. So as you practice, know what you need, know what you're trying to find, okay? I just found the distance from 0 to 5. But the question here asks us to compare the average speed from 5 to 6. And that's okay. Here comes the thinking part. Well, the first part's easy, right? The left side of the equal sign is easy. Like I said earlier, we know the distance is 2.5 blocks. We know the time is 6 seconds. So here in my work, I have 2.5 blocks divided by 6 seconds. So therefore you get 0.42 blocks per second. Again, you don't get the units here, but if you want, you can write it blocks per second, whatever it is that's given to you. However, in the second statement on the right, from 5 to 6, that's a whole new ballgame. And this is where if you don't know what you're finding, you're going to plug in wrong values and get the wrong average speed, and then your coefficient is going to be wrong. The numerator here is 0.76 because, well, we know from 0 to 6 seconds is 2.5 blocks. We know from 0 to 5 seconds, which I just calculated here in this column, is 1.74. Well, what's the distance from 5 to 6? Well, from 5 to 6 would be the leftover. So I would take 2.5, subtract 1.74. Therefore, the distance covered between 5 to 6 seconds is the difference, which is 0.16. And that's where the 0.16 block comes from. The 1 on the bottom simply comes from taking the difference in the time here. 5 to 6 is the difference of 1 second. So the denominator is just 1 second for that reason, okay? Therefore, 0.76 divided by 1 is just 0.76. And then we set up our ratio, 0.72 equals to, 0.76 with a blank. And here's my heart. And then to get heart by itself, we divide both sides by 0.76. And then it's going to come out to be 0.55. And that's it. So set up your baseline. Make sure you can write t in terms of the original t. So if you can pull out that coefficient, you should be solid for these types of problems. All right. I hope that helps. Stay nerdy. Don't be whack.